Hello. So these questions are in chemistry. So I'll start with question 3. So question 3, how many moles are in 4.8 times 10 to the, I assume, exponent 24 atoms of lead? Okay, so lead, the short form for lead is Pb. So let's start with this for now. And what do we have? Well, it wants us to find moles. Moles is denounced by the variable n. And the formula that your teacher may have given you is something that looks like this. N, which stands for moles, equals N over Na. Another formula you'll need is this one. N equals mass over molar mass. So these are the two common formulas you'll use in chemistry. So little n, this n stands for moles. A mole is just a quantity. And Na is Avogadro's number. So this is 6.02 times 10 to the 23. And n here is a number of particles. So usually, so I'm going to say number of things. So this first formula is what you will be using. Now another one you could be using is this one. N here stands for mole. The little m on top here, this stands for mass. And it's usually in grams. And the big M on the bottom stands for molar mass. And this is usually given on your periodic table. And the unit is usually grams per mole. Okay, so to solve this question, you have this much amount of atoms, and so this means that this is a number of things. So you have 4.8 times 10 to the exponent 24, and you just need to find moles. Na is a constant. That's Avogadro's number. It's always going to be 6.02 times 10 to the 23. And I'll plug it into your calculator, and then you should get n equals 4.8 times 10 to the 24 over 6.02 times 10 to the 23. So let's see. 4.8 times 10 to the exponent 24 divided by 6.02 times 10 to the exponent 23. You should get n equals 7.97 moles. So this just means that if there are 4.8 times 10 to the 24 atoms of lead, this means that there's 7.97 moles of lead. Now, on your calculator, be sure to, you might have to put a bracket before you plug it into your calculator. Otherwise, it may not calculate it properly. But regardless, your answer should be 7.97 moles. Now, for strontium, okay, so how many grams are in 5.3 times 10 to the 23 atoms of strontium? So let's see. So first, we need to figure out how many moles this is. Okay, so using the same idea, let's see here. So we have N, so this is for strontium. I'm just going to draw a little line here, just to not get confused. So strontium, so N equals, so number of things, so atom, 5.3 times 10 to the 23 over 6.02 times 10 to the 23. Now remember, the bottom part, Na, it's always 6.02 times 10 to the 23. The top part, in this case, it's atoms. We're just using this to find out how many moles there are. So let's see here. So N, so how many moles are there? 5.3 times 10 to the exponent 23 divided by, make sure you put brackets on your calculator. And you should get 0.88 moles, but you're not finished yet. Like I said, you may need to put brackets on your calculator. Many beginner chemists don't do this, and then they don't know why they get a different answer. Okay, so now you have moles. Now, equation 1 we're finished with. In this one, we need equation 2. Because this is how we're going to get grams. So, N equals mass over molar mass. Molar mass, I've already figured that out. You look it up on the periodic table, strontium, and it's 87.62. You can also Google it, and you get 87.62. But keep in mind, depending on the periodic table your teacher uses, it may be off by a few decimal points, but usually not by much. But for this case, let's use 87.62. So in this case, let's plug it in. So moles equals mass over molar mass. Moles is 0.88 moles. Mass you're trying to find out, and molar mass, we've looked it up, and it's 87.62. Multiply together, your mass should be 87.62, 77.1 grams grams of strontium.